Hi to all, how are you? Today's topic is dielectric. Now what is a dielectric? The substance which do not have the free electrons. The substance which do not have the free electrons. The substance which do not have free electrons. This substance not have the free electrons. Okay, is called as dielectrics. Dielectric is a substance, it does not have the free electrons. The substance which do not have free electrons is called as dielectric substance. Example for the dielectrics: glass, mica are the examples of the dielectric. The substance which do not have free electrons is called as dielectric. Example: glass, mica. And the dielectric substances are two types. These are two types. What are they? The first one is non-polar dielectrics. What is that? Non-polar dielectrics. What is non-polar dielectric? The second one is polar dielectrics. And what is polar dielectric? And that we are going to discuss. The first one is what? Non-polar dielectrics. Let us start with the non-polar dielectrics. Non-polar dielectrics. What is non-polar dielectrics? Non-polar dielectrics. This non-polar dielectrics is a substance. It consists molecules. Okay. In that molecule, every molecule has positive charged protons and negative charged electrons. Because every molecule is made up of atoms and every atom is made up of protons, electrons, neutrons. That means every molecule contains atoms and every atom contains the protons and electrons. And if all the positive charge of a proton concentrate at one point and all the negative charge of a molecule concentrate at some other point, if that two points are coincide, that means positive charge and negative charge is coincide. That means whole positive charge concentrated at one point, at the same point if the negative charge is coincide, that means the center of positive charge coincides with the center of negative charge. Okay, then such molecule is called as non-polar molecule, right? Non-polar molecule. What is non-polar molecule? A molecule in which the center of positive charge coincides with the center of negative charge. Then such molecules are called as, such molecule is called as non-polar molecule. The substance which have the non-polar molecule are called as non-polar dielectrics. Example for the non-polar dielectrics: oxygen, nitrogen. These are some other examples. In these, the center of positive charge and center of negative charge coincide. And let us see here the positive charge. For example, in the absence of electric field, this will happen in the absence of electric field only. Okay, the center of positive charge coincides with the center of negative charge in the absence of external electric field. In the absence of external electric field. When there is no external electric field, the center of positive charge and center of negative charge are coincident like this. When center of positive charge and center of negative charge of certain molecules are coincide, then the dipole moment of molecule is zero. Dipole moment of each non-polar molecule is zero, and dipole moment of dielectric substance is also dipole moment of dielectric substance also equal to zero. Okay, what we are telling it here? The dipole moment of each non-polar molecule is zero. Why the dipole moment is zero? Because what is dipole? To equal and opposite charges separated by certain distance. This is called as dipole. The dipole moment direction is from minus q to plus q. Its formula is product of magnitude of charge and distance between the charges. Now in case of dipole, negative charge, positive charge should be there. There should be some separation. But in case of non-polar dielectrics, what happens? In case of non-polar dielectrics, center of positive charge and negative charge both are coincide. When both are coincide, there is no gap between them. That means the distance between the negative charge and positive charge is zero. When the distance is zero, then the dipole moment of each molecule is zero. Every molecule has positive charge and negative charge. The total positive charge and negative charge concentrate at the same point. That's why there is no separation between them. And when there is no separation, then the dipole moment is zero. When the dipole moment of one molecule is zero, automatically the dipole moment of substance is also zero, because every molecule has zero dipole moment. The combination of molecules gives the substance. Substance is a group of molecules. Every molecule has zero dipole moment, means substance also has a zero dipole moment. Okay, and now the substance have the zero dipole moment in the absence of electric field. Okay, if a non-polar dielectrics in the presence of if a non-polar dielectric is placed in external electric field, if non-polar dielectric is placed in external electric field, then what happens? Okay, when we place the non-polar dielectrics in external electric field, what happens? Okay, let us see, and let us consider when we place the non-polar dielectric. This is the non-polar dielectric, right? Non-polar dielectric. In non-polar dielectric, positive charge will be there and negative charge will be there. They are coincide, right? They are coincide like this. These are the molecules. Look at here. This is a molecule. This is a molecule. This is a molecule. This is non-polar dielectric. Dielectric means it is a substance, right? The substance which contains the non-polar molecules. Non-polar molecule means what? Center of positive charge and center of negative charge are coincide. This is in the absence of external electric field. external electric field, right? When there is no external electric field. In the absence of external electric field. When there is no external electric field. In the absence of external electric field. In the absence of external electric field, in this case, the dipole moment is 0. The net dipole moment is 0. The net dipole moment is 0. Why the net dipole moment is 0? Each molecule has 0 dipole moment. That's why the net dipole moment is also 0. Right? Net dipole moment is 0. Why? Each molecule has 0 dipole moment. No separation between the plus and minus. If we place this in the external electric field, right? I am placing the non-polar molecule in external electric field. Do you know how to give the external electric field? External electric field. Okay, let us see. We will supply the external electric field right side. This is the applied electric field. For how to supply the electric field? One side you keep the positive charged plate, other side you keep the negative charged plate. In between the two plates, let us try to keep the non-polar dielectric. Non-polar dielectrics has the non-polar molecules. This is a molecule, right? This is a molecule, okay? Molecule, this one. Molecule. And here, when this non-polar molecule is in the external electric field is right side, okay, away from the positive charge towards negative charge. Then what happens? Can you tell? The negative charges are attracted by this positive and positive charges are repelled by the positive. That's why they will become like this. This side negative will forms positive. This side negative will forms and positive will forms. This side negative and positive will forms. Okay, like this it happens. Negative, positive. 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 Okay, look at here. This positives repels the positive. That's why the positive will displaces this side. Positive will move this side and negative moves that side. Then there is some separation between the negative and positive. Okay, that means in the presence of external electric field, what happens? Okay, if you place the non-polar dielectric in external electric field, here this molecule does not have the zero dipole moment, because in external electric field there is some separation between the negative and positive charge. Then we can give the conclusion: in the absence of external electric field, the net dipole moment of molecule is 0. Each molecule has dipole moment 0. And dielectric is the combination of molecules, that dipole moment also 0. This is in the absence of external electric field. Now if we give the external electric field, then what happening? There is increase in separation between the positive and negative charge. Due to the increase in separation, there is some non-zero dipole moment, right? There is some length is there here, distance between the charge, negative charge and positive charge is there. That means here negative charge is there, here positive charge is there. There is some separation is there. That means dipole moment also there, right? Here dipole moment is not zero, right? We write conclusion: in the presence of external electric field, in the presence of external electric field, in the presence of external electric field, what happens? net dipole moment in the presence of external electric field, net dipole moment of each molecule and dielectric is not equal to 0. Not equal to 0. Right? And this is net dipole moment is not equal to 0. That is in the presence of external electric field. Okay. Now let us see. When a non-polar dielectric is placed in the external, okay, in the presence of external electric field, the net dipole moment of molecule and the dipole moment of dielectric is not equal to 0. Why? If there is no external electric field, positive and negative charge are coincide. There is no separation between them. That's why dipole moment is 0. If electric field is applied, there is some increase in separation between the positive and negative charge. Due to that, the net dipole moment is not equal to 0. Right? And this is about non-polar dielectrics. And the next one is, let us discuss about the polar dielectrics. Second type of dielectrics are the polar dielectrics. Polar dielectrics. What are the polar dielectrics? Polar dielectric is a substance, right? It contains the molecules. In the absence of external electric field, the absence of external electric field, the center of positive charge, of molecules does not coincide with the center of negative charge. Means center of positive charge and center of negative charge, they are not coincide. Then such molecule, if they are coincide, that is non-polar molecules. Polar means that they cannot coincide. In the absence of external electric field, the center of positive charge does not coincide with the center of negative charge. Such molecules are called as what? Such molecules are called as polar molecules. The substance which have polar molecules, the substance which has polar molecules is called as polar dielectrics. Right? This is about polar dielectric. Example for the polar dielectric molecules: HCl. HCl is the example, and one more example is CO2. These are the examples of polar dielectric molecules. There is center of Cl does not coincide with each other. Okay, that means there is some separation between them. And how the diagram will be there, let us discuss. In the non-polar molecule already we discussed. Now I am continuing with the polar molecules. Let us see. In case of polar molecules, in the absence of external electric field, there is some separation between the positive and negative charge centers, right? And let us see like this, it will be there. This is minus plus, this is plus minus, this is plus minus, and this is minus plus, plus minus, minus plus, minus plus, and minus plus, like this. There is some separation between the molecules. This is one molecule, and this is dielectric. Okay, which dielectric it is? We are discussing the polar dielectrics now. Polar dielectric in the absence of tell me, external electric field. In the absence of external electric field. In the absence of external electric field. Okay, look at here. There is some separation between the negative and positive charge. They are not coincide. They are not coincide. Center of positive and center of negative charge does not coincide. That means each molecule have the dipole moment. Each molecule behaves like one dipole, minus q and plus q. There is some separation. That's why each molecule has dipole moment. That means dipole moment of each molecule. Dipole moment of each molecule is not equal to 0, right? Is not equal to 0, right? Okay, the dipole moment is not equal to 0. But one dipole moment, if it is dipole moment direction right side for this molecule, okay, some another molecule it is left side, minus 2 plus, minus 2 plus this one, and some other molecule we will take here, okay, this is minus and this is plus, like this it will be there. There is this molecule and this molecule dipole moments are opposite direction, and this molecule and this molecule dipole moments are opposite direction. Like this, what happens? Okay, one dipole moment is cancelled with the other dipole moments. This side will be there for this dipole moment, minus 2 plus, for this like this will be there. Then the net dipole moment of the dielectric will become 0, right? Because the dipole moment of one molecule cancelled with the other molecule, because these dipole moments are randomly distributed. Okay, then we say that net dipole moments of each molecule are in different direction. That's why the net dipole moment of polar dielectric in the absence of external electric field, tell me, external electric field is equal to what? 0, right? Is equal to net dipole moment is 0. Every molecule has the dipole moment, but the net dipole moment is 0. But in case of non-polar, positive negatives are coincide. That's why each molecule dipole moment is 0. Like this, several molecules are there. Every molecule dipole moment is 0 means automatically dielectric dipole moment also 0 in the absence of external electric field. in case of non-polar dielectrics. But in the presence of external electric field, what happens? Let us see. In the presence of external electric field, if we apply the external electric field, what happens? Now let us see. This is our dipole, and here this side positive charge capacitor, this side negative charged plate of capacitor. Now electric field is right side. This is applied electric field. Okay, applied electric field. And here this dipole is in the external electric field. On this dipole torque will act. Due to the torque it will be rotates, and all the dipoles will align like this. All the dipole will align like this. Minus will come to this side and plus will goes to that side. Then all the dipoles are arranged in particular direction, right? Like this. That's why what happens in this case? This is polar dielectric. Polar dielectric. In the presence of external electric field, right? In the presence of external electric field. What happens it here? Every dipole has the dipole moment, right? Like this P. That means now each dipole moment, molecular dipole moment is not equal to 0. Molecular dipole moment and dielectric dipole moment is not equal to 0, right? Molecule dipole moment not equal to 0, and dielectric substance not a dipole moment. Dielectric means all the molecules dipole moments are added, means dielectric. Dielectric means substance means number of molecules. All molecules dipole moments added means you will get the dielectric dipole moment is also not equal to 0. This is the behavior of dielectrics in the external electric field. Let us see. If we place one dielectric in the external electric field, how much charge induces in it? That I am going to tell. I am going to explain. Almost we discussed the behavior of dielectrics in the external electric field. Once again we will revise it. Now the topic is behavior of dielectrics in the external electric field. In the external electric field, I am going to explain the behavior of dielectric. I am going to discuss the behavior of dielectrics in the external electric field. I am going to explain the behavior of dielectrics in the external electric field. Look at here. Behavior of dielectrics in the external electric field. This is our topic. Okay. If we place any dielectric in the external electric field, then what happens? What is its behavior and what changes will occur? That we are going to discuss. Okay, this is the last topic in this chapter. And with this our chapter will complete. The second chapter is electrostatic potential and capacitance. Behavior of dielectrics in the external electric field. Let us see external electric field. How to create the electric field? Do you know? Right. One positive charged plate is required this is the positive charged plate and this is the negative charged plate. In between the two plates, electric field will be produces, right? Electric field will be produces. Let us consider E is the applied electric field. E is the applied electric field. Applied electric field. Can you give the formula for the applied electric field? At here, electric field due to positive plate will be there, E1. Okay, E1, right side. Electric field due to negative plate also there, that is E2. The net electric field is E1 plus E2, because electric field due to positive away from the positive, electric field due to towards negative, right? Net electric field is E1 plus E2. Due to positive plate formula, sigma by 2 epsilon naught, sigma by 2 epsilon naught, then sigma by epsilon naught we will get. This is E is the applied electric field. The formula for the applied electric field is sigma by epsilon naught, where sigma is surface charge density. Surface charge density. Okay, let us surface charge density sigma also we can write. Okay, sigma we can also write charge by surface area. Q is the charge on each plate. Charge on each plate. On this plus Q charge, on this minus Q charge. This is the A is the area of each plate. Okay, right. And this is equation 1. Let us consider applied electric field. In this electric field, okay, in this electric field we are placing one non-polar dielectric substance. Okay, one dielectric substance we are placing. We are placing one dielectric substance. This is a dielectric substance. When we place the dielectric substance in the external electric field, what happens? You know already, right? In this, the negatives will goes like this and positives will goes another side. Then this will be displaces like this. Negative, positive, negative, positive, negative, positive. Negative, positive. Why? All the negatives will attracted towards the positive plate and all the positives attracted towards negative plate. In this positive and negative are nearer to each other. They will cancel with each other. This positive, negative, they are also nearer to each other and they will cancel with each other. Like this positive and this negative. Okay, like this, positive, negative, these are all will cancel, and at that moment this positive will cancel with this negative, almost like this, totally will cancel. Like this. Look at here. In this positive, negative, positive, negative, positive, negative, positive, negative, positive, negative, they will cancel, and that means there is here negative charge is there, this positive charge is there, and that will never cancel with each other because there is some separation. And now due to this, some negative charge is induced on the left side and positive charges will be induced on the right side. The equivalent diagram also we can draw like this, and this is positive charged plate and the positive charge is plus Q, and this is a dielectric, and this is the negative charged plate. In this case, what happens? Some of the negative charges will induces this side, some of the negative charges will induces this side, and some of the positive charges will induces that side. Okay, and remaining in the middle there are some positive and negatives, they will cancel with each other, and this is induced positive charge. Okay, and this is plus q and this is minus q, and here some induced negative charge is there, and this is induced positive charge, this is induced charge. Okay, induced positive charge plus q suffix I. Okay, and here negative charge is induced, in the middle there are some charges are there, they will cancel with each other. Let us see, due to this induced charge some induced electric field will be there, this side induced electric field will be there, right, and induced electric field is this side will be there, induced, applied will be right side will be there, plus 2 minus, applied is this one positive plate and that one is negative plate, this is the positive charged plate and this is the negative charged plate, applied is positive to negative, right, induced, this side positive is induced, this side negative is induced, electric field is left side will be there, this is the induced electric field, right, induced electric field is left side. Induced can be denoted with E suffix I, applied is E, applied is E. Okay, applied right side, induced left side, this is the induced electric field, the induced electric field will be left side and applied electric field will be right side, applied electric field is right side. Okay, now let us write the formula for the induced electric field. Okay, let us write the formula for induced electric field. Induced electric field, right, induced electric field, let us write induced electric field as induced E suffix in, E suffix I, induced electric field is equal we write as induced surface charge density by induced surface charge density by area, right. And now let us see, this is equation 2 and here what is sigma I? Sigma I is the induced surface charge density. What is that? Induced surface charge density. Okay, how to write the formula for sigma I? Induced is induced charge by area. Okay, and electric field formula, sorry, this is not electric field formula. Electric field formula is induced charge sigma by epsilon naught, sigma by epsilon naught. Okay, induced charge by area. And now let us see, Qi is what at here? Qi is the induced charge in dielectrics, induced charge in dielectrics. And what is A? A is the area of each plate. Now let us see, net electric field I want to find out. I want to find out the net electric field. Okay, how to find out the net electric field? There are two electric fields are there. Applied electric field is right side and induced electric field is left side. Now I want to find out the net electric field, right? Net electric field. Can you tell how to find out the net electric field? That is, net electric field is equal, net electric field is equal, applied electric field is what? E, right side. Okay, minus induced electric field is left side. We have to subtract them. I want to find out the induced electric field from this. Then induced electric field is equal to applied electric field minus net electric field, right? Net, E suffix net. E suffix I means induced, E net electric field I want to find out. Applied is right side and induced is left side. The net is we have to subtract because they are in opposite direction. Net electric field equal to E minus EI. In that EI formula I want EI is equal to E minus E net. Then what is, but we know, but E is equal to net electric field intensity. net electric field intensity in dielectric we know already, that is sigma by k epsilon naught, right? Sigma by k epsilon naught, where sigma is surface charge density, that we write as charge by surface area, charge by surface area, or otherwise we can write later also. But E is equal to sigma by k epsilon naught, and I is equal to E net is this one, net electric field. Net electric field means in dielectric electric field. In dielectric electric field. Electric field in dielectric. Formula is sigma by k epsilon naught. And E for E is the applied electric field. Applied electric field formula already we know, sigma by epsilon naught. Okay. Now this we substitute in above equation. Then induced electric field is equal, we get as sigma by epsilon naught minus sigma by k epsilon naught we will get. Then induced electric field formula we will get as sigma by epsilon naught is common, we will get 1 minus 1 by k, right? And sigma formula is also known, we write surface charge density, that is q by a, we write as q by epsilon naught a into 1 minus 1 by k. And now induced electric field we write as induced surface charge density by area, right? Sigma I by a we write sigma I. This is the net electric field formula. Either we use this induced electric field formula or we use this. And from this I want to find out the induced charge. How to find out the induced charge? Then induced electric field we write as sigma induced by epsilon naught is equal to q by epsilon naught a into 1 minus 1 by k. This is induced electric field formula we know. Induced electric field formula is E suffix I. Induced electric field formula E suffix I is equal to, what is the formula? Sigma induced by epsilon naught. Now sigma induced charge by area we write. Okay, from this induced charge by area we write. Induced charge by area is equal to q by epsilon naught a into 1 minus 1 by k. From this will cancel. Then finally we will get one formula for the induced charge, right? Now the induced charge formula we will get is q suffix I is the induced charge is equal to 1 minus 1 by k. This is the formula for induced charge. Okay, how much charge induces in the dielectric, that we can find out by using that formula. Okay, and now the next one is dielectric polarization. And this some charge is inducing, that induced charge in the dielectric we can find out by using that formula. What is the formula? Induced charge formula is, finally we got applied charge. Here on the plates we are giving some charge into 1 minus 1 by k, where k is the dielectric constant. Okay, and the next one is dielectric polarization, the last topic. Okay, within 1 minute our topic will complete. Okay, and now let us see what is dielectric polarization. Okay, dielectric polarization. Dielectric polarization. Dielectric polarization, this is capital P. It's not dipole moment. Okay, dielectric polarization is the induced dipole moment. Induced dipole moment per unit volume. Induced dipole moment per unit volume is called as dielectric polarization. Dielectric polarization. Okay, dielectric polarization formula is dielectric polarization is equal to induced dipole moment when an dielectric is placed in the external electric field, some dipole moment is induced, that is induced dipole moment by volume, that is called as dielectric polarization. Okay, and let us see this dielectric polarization formula is, we write induced dipole moment by volume, we write. And here induced dipole moment, how we will write? Induced charge into dipole length, we write, by volume. For example, we are placing a dielectric in the shape of cube. Its volume we write as area into length. This side positive charge we will keep, and this side negative charge we will keep. There is some negative charge induces this side and a positive charge induces this side. Okay, and the negative charges will be induces this side. What happening at here? This is the applied electric field. We are applying the electric field for the cube. This is a cube, and now this is the separation. 2L is the separation. Okay, and A is the area. We write in this some charge is inducing on the left side, negative attracts this side, positive attracts that side. That's where some charges induces on the both sides. Okay, and now volume we want to write. Volume of this cube is area into length. 2L we write. This will cancel. That is, we will get as Q suffix I we have to write. This is equal to induced charge by area, and this is also equal to, we write as induced surface charge density. Okay, and now dielectric polarization numerically equal to what is this? Induced surface charge density. Okay, surface charge density. Why we are telling it as induced surface charge density? Because here we have Qi is the induced charge. Induced charge by area gives the induced surface charge density. Dielectric polarization is numerically equal to the induced surface charge density, right? And this is dielectric polarization. This is equal to surface charge density. And one more point is that, note, the dielectric polarization is proportional to external electric field. Okay, external electric field. That is, dielectric polarization is equal proportional to E. And now when we remove the proportionality, we will get some constant, that is xi. This is called as xi, and this is electric susceptibility. It is called as electric susceptibility. It depends upon nature of dielectric. It depends upon nature of dielectric. Okay, and with this our electrostatic potential and capacitance second chapter successfully we completed. Okay, little bit fastly I said this last topic, and if you have any doubt you can ask me, and you can comment how is my lecture. You can comment in YouTube. Thank you for watching my lectures, and subscribe my channel, share to your friends. Have a nice day.